In lesson 99, we're looking at absolute value inequalities, absolute value conjunctions, absolute value disjunctions, and the negative numbers and absolute value. So the first example is just the general absolute value inequality. Okay, you have to set up two different inequalities because when you take the absolute value of a number, if it's negative, it becomes positive. If it's positive, it stays positive because we're talking about distance from zero. Okay, so I'm going to set up two different inequalities. One, it basically stays the same. I have x is less than or equal to 4, and then my other inequality, I have x is greater than or equal to negative 4. And notice that whenever we start out with the absolute value all by itself and it's less than, then we have an and statement. If we start out with the absolute value and it's greater than, then we end up with an or statement. Now we can go ahead and start our graph. Notice that it's integers, and then we have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and it has the equal to sign, so we do include both the negative 4 and positive 4. So x is greater than negative 4 but less than positive 4, and then it's integers, so we just use the dots because we don't want any fractions. And that is the absolute value graphed. Alright, let's look at the second example. This one's a little bit more difficult just because you have to get the absolute value by itself first before you set up the two inequalities. So I'm going to move the 3 to the other side. So I have negative absolute value of x is greater than negative 3, and then I would multiply or divide by negative 1 to change the signs. So I have the absolute value of x is now less than a positive 3. And now I set up the two inequalities, and it's starting out with a less than, so I'm going to have an and statement. So I have x is greater than negative 3. So I flip the sign and change the sign. So flip, change. And then for the other one, it just stays the same. X is less than 3. And again, it's integers. So I have negative 3, negative 2, negative 1, 0, 1, 2, 3. This time it doesn't have the equal to lines under it. So I go with the negative 2, negative 1, 0, 1, and 2, and don't include the negative 3 and positive 3. Alright. On the next one, we do the same thing and get the absolute value of x by itself. So I have negative absolute value of x, and then I'm going to subtract that 2, so it's less than negative 4. And I have the absolute value of x is greater than a positive 4. Okay, so since this starts out with a greater than, this will make an or statement. So I have x is less than negative 4, or x is greater than a positive 4. This time it's the reals. So I have, here's my negative 4, positive 4, open circle because it doesn't have the equal to line. And this is less than, so I'm shading to the left where the numbers get smaller. I do not know why it keeps rejecting my shading. Alright, then this is open, shaded to the right. There we go. Similar to that, best I can do with it deleting my lines for some strange reason. Alright. Then on example 4, we've got two special cases here. So in the first one, x, the absolute value of x is less than -2, and our domain is the real numbers. Well, because that's an absolute value, you're never going to get a number that's less than a negative number. So this ends up as no solution or an empty set, okay? Because you're never going to have a negative number come out of that absolute value. So it's always going to be greater than a negative number. Okay, and then on the other example, we have the absolute value of x is greater than -2. Well, in absolute value, it will always be greater than a -2. So on this one, they would be all real numbers. We include all numbers, both negative infinity to positive infinity. So all the numbers would be shaded. Okay, in example 5, this uses one of our special cases that you have to recognize. So let's get the absolute value by itself. So we have negative absolute value of x, add that 5 to move it to the other side. It's greater than 2. Then we have to change the signs by either multiplying or dividing by -1. So we have the absolute value, then it's less than -2. So absolute value never going to be less than a negative number, so this is going to be no solution, null set, empty set as our answer. Oops. Anyway, I hope this helps. If you have any questions, feel free to email me.